Hello, and welcome back to our Let's Build session about IoT. And today we are going to show you how to create a control in your environment. In this case, we are looking forward to control the food storage to monitor the temperature and humidity, and then we can react, send messages, notify someone, trigger some alarm, or turn on or turn off like heater, lamps, and things like that. So a lot of fun using AWS IoT Core and ESP32. So I'm Vinicius Sanger, and I'm presenting this Let's Build IoT session together with Ana Cunha, and we both work for developer relations team at AWS. So welcome. You will need to have an ESP32 module working with Arduino and AWS IoT Core. If you don't have it, you can watch our first and second episode so you can set up everything from scratch. Once you have it, you are good to go here to this number 3 and do this cool project. So we are using a temperature and humidity sensor. This one, AGC1080, is a very good one, is high precision, much better than like the cheaper one that is called DHT11. Here we have very good data from the sensor, and it's also I2C sensor. I2C is a way to communicate with sensors, and it's very easy to plug and start playing with this guy. And it has libraries for Arduino. We need wires, so female to female wires, male to female wires, so you can plug and hook up the sensors into your ESP32 or to your protoboard. So you need a 5 volts relay if you want to control lamps or like any kind of appliance or turn on and off energy from any kind of source, AC source. And it's a good idea to have a protoboard so you can put the things together in a more organized way. The total cost, at least here in Brazil, it's hard to say because it can vary a lot from country to country, but the total cost here in Brazil, it was around like 25 bucks to buy all the components that you need, including the ESP32. So that's the circuit to wire up the temperature and humidity sensor. Basically, what we have here is a red wire, that's the 3 volts. Take care, because it's 3 volts. Don't plug it on 5 volts because you can burn the sensor. And you have the ground, the black one. And we have 2 wires, the yellow and blue one, that we are using to communicate using I2C ports. You can see here 21, 22 are the I2C ports on our ESP32 module. So very easy, just 4 wires. Take care with the energy one. The red one is 3 volts. This sensor is 3 volts. So the level, it's very dangerous because we have both. We have 3 volts that came from a regulator, voltage regulator, and we have the 5 volts that came from the USB port. So the relay board is also very simple. It's very important that you buy a 5 volts relay, so you don't need external power source like you have relays in 9 volts, 12 volts. In this case, since we don't have 9 volts and 12 volts in our ESP32 board, you need an external power source. It's much harder to wire up. If you buy a 5 volts relay, you can take the energy direct from the ESP32 board. So 2 wires, the red one and the black one, and 1 wire to control the relay. And you can choose any digital port to do it. We will see soon the code that we are going to write. You need to put the number of the port that you are using to plug your relay board. My circuit, I did this panel because I like to organize the things in a better way. Sometimes we travel to do live demos. And so I have here my protoboard. I have the button that we used in the previous episode to do the call waiter button. And then I have here something different. I'm bringing the 5 volts to the protoboard, and then I'm taking the 5 volts for different proposals here. So, but you can take it out the protoboard if you don't have the IoT button. You can plug direct straight to ESP32. So you can see here my wires for the temperature and for the temperature and humidity and the relay board. So, and here I'm plugging AC. So I have a lamp that I'm really controlling. So take care when you do this kind of connection, because AC is high voltage. Any kind of problem that you can have with this wire, you can really generate big explosions, trust me. So you need the code for sure. We are going to use a pre-coded Arduino firmware. So I will show you and explain all the details around this Arduino firmware, and then we are going to see how it's working with AWS IoT core services, and then we are going to explore what we can do once we are receiving the message from the sensors, how we can store the data using like DynamoDB, how we can call a Lambda to react to the environment, and have a lot of fun. All right, so let's build, let's get our hands dirt. And now I don't have more slides. I just have 2 final slides in the end. So it's all about coding. Let's start showing the Arduino code. That's the code that you can find in our GitHub repository. So here we have some libraries that we are going to use to connect to our Wi-Fi. And we are including Wi-Fi, DNS, UDP, Wi-Fi client secure, and QTT clients that we need to send messages. We are including our secrets with our certificates that is right here. And the library for the temperature and humidity sensor, the closed cube AGC 1080. So you need to install this library. It's very easy. You just come here and say manage libraries. And then from here, you can look at like 1080. Oops, updating 1080. Closed cube ADC 1080. It's already installed. If you don't have it, you just click here, install, and boom, done. We are also using Arduino Json, which is a very nice library for manipulated JSON in a better way. So that's the library, that's the name of the creator, the author. And then you just click install and boom, done. Okay, so that's 2 libraries that you need to install. And here we have the host name, Let's Build. That's our host name. We are configuring our Wi-Fi credentials and ID. We have some names of topics that we are going to publish the sensors data and also the button. And we have a topic that we are subscribing to control my lamp here. So then we are creating some objects to communicate using the Wi-Fi and using MQTT. We are creating the thing name. This guy we are not using. We are creating an instance of this class that represents our sensor. We are defining the table number for the call waiter. This project is the final project with everything included. And we have the button. The call waiter button is plugged on port number 23. And the relay, we are using the 27. If you choose a different one, you just change the define here. In the setup, that's the method that Arduino just runs once. We are configuring our serial communication. We are creating the pull-up for our button. We are configuring the relay so we can control the digital port instead of reading. We are initializing the temperature and humidity sensor using the begin. And this address is the I2C address. The nice thing about I2C is that you just use 2 digital ports from your ESP32 and you can hook up different sensors with different addresses, and then you can say like, I want to communicate with this sensor that is hosted on this hexadecimal address. And then we are initializing the temperature and humidity sensor. Here we are attaching the interrupt, as we showed in the last episode in the number 2 in the call waiter button. I'm not going deep in this code. And then we are calling the connect Wi-Fi and connect AWS. So those methods will help us to start the connection with our Wi-Fi, and then we are connecting to AWS. We have some variables, temperature, humidity. We have the last sensors sending. We have the sensor, the variables that we used for the call waiter button. And in the loop, we are going to say client MQTT client dot loop, right? So client is right here, so it can check if we received any kind of new MQTT message. We are going to read the temperature and the humidity and store in our local variable, and then we are going to say that digital write, this guy we are not using anymore, sorry. Now we are saying that if the time less than last sensor's reading, that is 0, okay, is more than 1,000, then I want to read the sensors and send the data, okay? So this way, we don't want to use delay. If you are familiar with Arduino, you know that you can put delay, like 1 second, and then the microcontroller will be waiting 1 second and then send the data to the cloud. So here we have the button and we have the sensor. And in this case, we are going to do 2 things. And if we use delay, we can have some delay. Here we are going to use this technique because we have more asynchronous coding. And then we just say here sensors and last sensor sending equal to milliseconds from Arduino. So we update and then loop until the difference between the time, the actual time, and the last reading is more than 1,000 milliseconds. It will not send the sensor's data again. And here is the code for the call waiter button, right? So if send message, send MQTT button message. That's the interruption function. So here we have the debouncing that we are doing. So we don't want to, if the user press like 3 times in less than 400 milliseconds, we just want to send 1 message. That's the nice thing behind this code and behind using interruptions. Like even if Arduino is doing some delay and we have an interruption, it will stop the delay and execute this code. The problem is that I cannot send any kind of MQTT message inside the interruption function because we cannot do like a long period. We cannot stay long period inside interruption function. So take care. What we are saying here is that if someone just presses the button and we just turn on the flag send message and update the last button timestamp, and then in the loop, if send message will send MQTT. So we have like 2 tasks running here, and then if we use delay, we can have problem to have both of these operations running. So that's the method that send MQTT button message that we already know. And the sensors, we are going to create a JSON string here with the device time, device name, the humidity, the temperature, and then boom, we are going to publish in our topic that is food control / sensors. And here we have the connect Wi-Fi. That's a very standard ESP32 Wi-Fi connection code. Nothing new here. And then finally, we have the method to connect to AWS using the credentials, cryptography, and then we connect, and then we subscribe to the topic control / lamp, and then we just have the message handler here, right? Because we configure that on message handler. So if someone publish in this topic control / lamp, we are going to receive the message, and if it's 0, it will turn off, turn on, and if it's 1, it will turn off. So it's the opposite, right? So that's the Arduino code. That's not very simple, but it's complete and it's working very well. And you just need to update your secrets and have fun with this code. So let's see the cloud side of the moon and which information we have there. So let's go straight to our AWS IoT Core console, and let's go to MQTT test client. That's nice. I don't need this window here. And then you can see that I have the subscription. Let's do it again. Okay, so let's subscribe to food control / sensors. Subscribe. And boom, I have each 1 second. We have the data coming here. So let's build the humidity, the temperature, 25. That's nice. I'm going to put my hand here. The temperature is increasing. That's good. And now let's subscribe to the button. Let's check the name of the topic. Call waiter / button, right? Okay, let's subscribe to it. And then I'm going to press the button. Pumba. 1 time, 2 times, 3 times. So you can see here I have the device name, the table number, and everything. All good. And now let's publish it to a topic. And the topic is control / lamp. And then I'm going to send 1. Okay, turn off the lamp. Turn on the lamp. So for you, I have another camera here. That's my secret. Like, this is my hand, so it's real. That's cool. So again, 1 to turn off the lamp and 0 to turn on. We could change the logic here. And so everything working very well, very responsive, and receiving all the data here from the sensors. And so now you have your board, you have the circuit, how to make the circuit. And now, what is next? Well, we want to store the data in our DynamoDB. That's my preferred database these days. So here we have a table called restaurant data. The primary partition key is the device name, the primary sort key is the timestamp, and then we could write a Lambda function to write the sensor's data there. But we have here a very nice feature called act. You can create rules. I did the rule here, restaurant data. Look at that. That's so cool. Select everything and timestamp the computer, the cloud timestamp. okay? Not the device timestamp, because in the device, we don't have a real-time clock. The timestamp that came from the device is the timestamp since it was turned on, okay? So we are aggregating, we are grabbing all the data that's coming from the food control / sensors, plus aggregating the timestamp that represents the time we received the message in the cloud. But you can see here that is food control 11. So it's not putting the data here, adding the data here actually. So that was just to make the live demo faster. And what I'm going to say here, actions, split message into multiple columns of DynamoDB. You can add multiple actions. You have many different types of send message to a Lambda function, SNS, SQS, Kafka, Kinesis, republishing a different topic, storing S3 bucket, very good idea for machine learning, Firehose, CloudWatch. You can create like a very simple dashboard using CloudWatch, Elasticsearch, and much more. Salesforce. So that's very nice feature. Let's come back here. So I'm going back here and I'm going to fix this name of topic. We are dealing with JSON the same way that we deal with SQL tables. So we are using SQL with JSON. So that's important that your device send JSON data to the cloud, to AWS IoT core service. Update, and then boom, let's see, fingers crossed, and now that's here, the data is coming and arriving, and now good. So you see that I just have one line of code that is this SQL code to grab the data from the topic and to take the action to store, to split the message into multiple columns of DynamoDB. So you can take many advantage of that because it's almost codeless, right? No code development. So, and the other thing we can do, I have here the restaurant lamp control. We can say select from topic, food control / sensors 1, just to not be triggering, and then send a message to a Lambda function. Here is just a very simple example. This Lambda function, let me show you here, IoT button Lambda. Here we go. What we are doing here, we are receiving the IoT message, the JSON, right? And what we are doing here is if event.temperature, the JSON dot, any field that we have there, temperature, humidity, you can check the device name, turn on relay, else turn off relay. So that's not the best architecture because the best architecture would be to do it in our firmware. I'm just using this example to show that you can call a Lambda and you can react to that. So here I have this code and turn on the relay. I'm going to send control / lamp, the payload 1 to turn on the relay and 0 to turn off the relay. So it's the opposite, more or less the opposite here. Let's invert the logic here. Okay. So, no, this way is the best way to control. I will explain. So now let's fix the rule here, the topic name, restaurant lamp control, and then we are going, it was 20, let's see how much, 27, right, okay. And let me see which temperature we have here, 25. So now I'm going to put my hand near from the sensor. My hand is hot. And then let's see, we need to see if it will turn off the lamp or turn on the lamp. So let's see. Okay, good. The temperature was very high. Let's see again. 25. Oops. Oh, I just turned off everything here. So let's try again. Okay. So the temperature is increasing a lot when I put my hand there. It's kind of crazy now. So that's very nice. That's not the right architecture because every time we are reading the sensor's data, we are calling the Lambda function. It will be very expensive, but if you need to do any kind of, it's just to show you what you can do using the Lambda functions, right? But take care with this kind of architecture. You can have a better logic on the microcontroller saying that if the temperature changed from X to Y, then call the message, right? And so that's it. Now, let's come back to our slide here. And if you want more, it's very easy to write an Alexa skill to control the lamps or to interact with IoT, AWS IoT services, okay? So I love to write Alexa skills. I have a repository called Internet of Healthcare on GitHub, and there we have from step-by-step how to create it. You can use Amazon Lookout for equipment, so you can grab this temperature and humidity sensors data and train a model and start predicting problems using the sensor's value from any kind of sensor. It's a kind of very, very nice way to use the AI ML, and you don't need to go to SageMaker. You can do a dashboard on Amazon QuickSight, for example, and you can use SageMaker, so you can have like a more sophisticated ML trained model. So you can use many other services, that just some ideas that you can go further, right? And all right, so we have this panel. It's not bad, but that's not a product, and I want to have 20 of these guys, each panel for one panel for each table that I have in my restaurant. Then I want to produce my own board. So we are really doing this in Brazil and exporting the project. This is the playground for IoT. It's an open source hardware project. Everything you can download in our repository, github.com/visenger/playground for IoT, and you can clone and you can produce this board. It has much more sensors like accelerometer, temperature, humidity, pressure, light sensor. You have a very nice display, OLED display, and you have like connectors for external sensors. And we have a circuit for plugging a secure element, so you can avoid to store the secrets in your code, and you can store the secrets in a very secure electronic component that you just can read the credentials. And you have also Playground for Robotics, that is a variation of Playground for IoT. It's also open source, that we created for producing robots like this. Very nice one that we are creating with sensors to follow line, distance sensor, and everything. So thank you very much for attending this Let's Build session.
Well, hello there, you amazing tech people, you. Listen, thank you so much for stopping by to check out this video. However, there is so much more great content out there to be found, so make sure to subscribe to the Build on AWS YouTube channel, and while you're at it, click that bell icon to be notified about the latest and greatest in videos made by builders for